Okay, today's lesson is solving linear inequalities, and I'm working through PowerPoint today, so slightly different look. If you're not clear on what I mean by linear or inequalities, that's okay. The lesson explains all of that. So just worry about solving for now. We're going to be solving something, and I'll explain what it is as we go along. So linear inequalities. A linear inequality is an inequality that contains an algebraic expression of degree 1. Let's just focus on the linear part of things for now. What I mean by that is that what we're talking about today will be degree 1 functions. And that sort of makes our life a little easier. We're not going to have x squareds, x cubed, all of that to deal with, just x's. And by inequality, well, okay, in just a second, you'll see what I mean by inequality here. Here's an example of some linear inequalities. And you can see when we see x values there, it's just x's we have to deal with. They might be on both sides, they might be buried in brackets, but I don't have x squareds, x cubed. We'll get to those situations, but first we'll go after linear ones that only have x's. And what's the inequality? Well, the symbol in the middle there is not going to be a equal sign. It's going to be a less than or equal to, greater than or equal to, less than, greater than. So that's why these are inequalities that we're solving here today. We can solve linear equalities similar to the way we solve linear equations. It goes very, very similar. Let's compare. Let's say I was given a linear equation, 3x minus 1 equals 8. How would I solve that? Well, I'd move the negative 1 over, or the subtract 1 over to the right-hand side and make it add 8, and I'd get 3x equals 8 plus 1. I'd collect the 8 and the 1 there and get 9, and then I'd divide by 3 to reverse the multiplying by 3. Hopefully that's like, yeah, of course, I know how to solve equations. Let's look at a similar one with an inequality in there instead of an equal sign in there. So say you were solving the inequality 3x minus 1 is less than 8. Very, very similar in the sense that it's got 3x minus 1 on the left and 8 on the right, but now a less than symbol in between. Let's look at the steps. You move the 1 over and make it add it, and you make it, that changes it to 9. You divide by 3 and you get x less than 3. So at first glance, nothing too different here. There are actually two differences we need to talk about. One, I'll get to on the next slide, is that in an equation you get one answer. Your final answer is just a number, x equals 3. Whereas in an inequality, your answer is x less than 3. It gives you a whole domain. It gives you a whole list of numbers. All the numbers less than 3 solve this inequality. And you think, well, that's really no big deal. Yeah, I understand that. I could see that on the last line, x less than 3. And so that's not a huge difference. It's just a difference in what your answer means. And maybe you're not shocked by that at all. The other difference, it's going to take a couple of slides to get to that. Don't worry about that just yet. I'll bring it up in just a minute. But for now, the difference between the two answers is that when we got x equals 3 in the equation, we have one answer. When we got x less than 3 in an inequality, there's lots of numbers to satisfy this inequality. And we can always represent the solution to our inequality in several ways. You've seen these ways before. Things like set notation, x element real such that x is less than 3. We can do with interval notation. These two brackets are indicating we're going to indicate a low x value and a high x value. And here the low x value is negative infinity with a circular bracket there. You cannot have a square bracket around an infinity because you can't really include infinity. And in this case, a circular bracket around the 3 as well because it wasn't less than or equal to. So you can see how the answer might change. If it was less than or equal to, we'd use a square bracket on that side. And you can also represent your answer in the number line like we did in the previous chapter. We're talking about all the numbers less than 3. And maybe the number line makes that clear that we're not just talking about the number 3, we're talking about all the numbers that are less than 3. And that's one of the differences with inequalities. Well, if that was the only difference, you might not need a separate lesson here. You might not even have to watch a video on it. Pretty straightforward stuff. So what you really watch this video for is what's coming next. So if you've drifted off to sleep or started to watch something else on YouTube, you may want to jump back in for this example because this is the big deal of this lesson. A seemingly harmless example. Doesn't seem like a big deal. Doesn't seem much different than the previous example. It says negative 3x minus 27 less than or equal to 0. Steps would seemingly be the same. You add 27 to both sides, and so I get negative 3x is less than or equal to 27. And then there's a big moment here. It's not a mistake on this PowerPoint. This is the right way to do this, and it's hard to understand why, and I've got to spend some time explaining why we do what we do. Then I divide both sides by negative 3, and do you see what happened? Why do we reverse the inequality sign when we divide or multiply both sides by a negative number. And I'm going to highlight that, and I encourage you to highlight that in your copy of the note and say, okay, why do we do that? Let's ignore that for a second. I'm going to explain why in just a second. I'm just going to finish it off. Just take it for granted that I'm going to explain something that goes, oh, I get why we have to reverse that now. And we'll just carry on with finishing the solution, which is I get x greater than or equal to 9. No big deal. But why do we reverse that sign? Well, there's the answer on the number line. X greater than or equal to negative 9. Notice the square bracket right there, or sorry, the filled in dot right there when we're doing x greater than or equal to negative 9. Okay, so now why was that thing reversed? Here's the other two notations here. X element real, I got x greater than or equal to negative 9, and here a square bracket on the negative 9 because we're including that answer. Okay, I need my pen here for a second to explain why that thing had to be reversed. And it's very, very strange. What color is going to show up best here? How about a red? Let's talk about how numbers are used on the number line. For instance, when we look at the numbers on a number line, I'm just going to do a few numbers on here. I'm going to do like 0, 1, 2, and 3. And this is my first attempt at explaining the issue here. I want you to take a look at the numbers 3 and 2. Notice that 3 is greater than 2. You're not surprised by that, because the number 3 is farther from 0 than 2. And I'm really trying to give you some extra weapons there by describing 3 differently than maybe you've heard it described before. 3 is 3 away from 0. 2 is 2 away from 0. So 3 is greater than 2. But look on this side. Negative 2 is greater than negative 3. That's a different result than we got on the positive side. When you switch over the negatives, we count backwards. We go down more and more negative as we go to the left. So the numbers get bigger, like the digits get bigger, but the number's value is actually getting less all the time. That's not the way we do it on the positive side. Bigger digits means bigger numbers on the positive side. On the left side, though, of 0, bigger digit means less values. So when you flip from one side to the other, from positive to negative, you got to reverse the order. Okay, maybe that just hitched onto your brain a little bit where you go, oh, I see what the problem is here. But let me do a very, very simple one. Let's say I write down the sentence, 3 is less than 5. No tricks. 3 is less than 5. There's no question about that. If I multiply or divide by a negative here, watch what happens. I'm going to multiply both sides by negative 1. I get negative 3 and negative 5. And I'm not going to put an inequality in between there. I'm just going to think about what's happened here. I've multiplied both sides by negative 1. And now think about it in your brain. Which one's bigger, negative 3 or negative 5? Negative 3 is the bigger number. And so by switching the sign on both sides of the inequality, I've switched the direction of the numbers. And so I have to flip this thing over. So let's just rewind for a second back to this example. This is a really big deal, what happened here to here. So if you do nothing else with this note, except try to understand why that happens, that when you divide or multiply by a negative, you've got to switch this inequality over. Okay, now all we have left is some practice problems. Some of them might have that little negative trick, some of them won't. If they don't have the negative trick, we've got nothing to worry about. And I'm not loving the red, so I'm going to try switching over to orange and see if I like the way that appears on here. So to solve this question, and there's a couple of ways you could do the steps here. For me, I do the distribution first, and I go, okay, I get 28x minus 42 is less than or equal to 42. And then I'd add 42 to both sides, and I get 28x is less than or equal to 42 plus 42. And I get 28x is less than or equal to 84. Then, to get x by itself, I divide both sides by positive 28. And since I'm dividing by positive, I'm not worried about switching this inequality, so it stays as less than or equal to, and I get 84 over 28. Well, I can do better than that. I'm going to divide top and bottom by 7, and I think I get 12 over 4. Oh, I can do even better than that. X is less than or equal to 3. Isn't that nice? It divided out beautifully like that. So x is less than or equal to 3. No big problem there. Again, examples like this you probably didn't need a video for. And why? because when I was dividing here, I was dividing by a positive number. So with inequalities, that's no big deal. Next example. Where is it? Solve the following inequalities. Okay. Again, I'm just going to do the distribution here, make my life simple. Negative 5x plus 15 greater than or equal to 2x plus 10. I'm going to bring the 2x over, so it's negative 5x minus 2x, and I got greater than or equal to 10 minus 15. I brought the 15 over in the same step. Simplify over here, I get negative 7x greater than or equal to negative 5. Again, that's all grade 9 type thinking, multiplying out some brackets, collecting like terms on the correct side of the inequality here. Those steps look exactly like they do in grade 9. You should be completely bored with that. But now, this final step right here, I've got to get x by itself, I got to divide by negative 7. And so what I get is x something. 5/7, I've just canceled those negatives there. And here's the big moment. When you are switching, when you're dividing by negative numbers, or you're multiplying by negative numbers, you've got to switch this inequality because the direction of everything switched. You'll get wrong answers if you don't watch out for that. That's the big deal of this lesson. See. Weirdly, for linear ones, doing these 3-part inequalities, where they're actually called double inequalities, where I have 2 less than signs, is actually no big deal. The only difference is you're going to be trying to isolate x in the middle. So when you're trying to isolate x in the middle, I'm going to go back to sort of a grade 9 method of dealing with this, so it's clear what's happening, is to this inequality, I'm just going to add 8 to all 3 sections of the inequality. So when you got a 3-part inequality, you've got to add or subtract or multiply or divide each section by the same number. So here I get 30 less than 2x less than 62. Really focusing on the middle part of the inequality. And the middle part, I want to isolate x. And here I got a 2x in there, so I got to divide everything by 2. And so I get 15 is less than x is less than 31. And once I get to that final answer, that should look a little familiar in that we've had domain statements before that had double inequalities like this. It's actually called a double inequality. I know I referred to it as a triple one there, so you sort of followed what I was saying, but it's called a double inequality. Incidentally, I'm just remembering there's a couple questions in the homework that sort of look like these that would be sort of unsolvable, and I'm not remembering exactly a question, but they look something like this. Where solving for x by itself in the middle is not really easy to do because it's not the same. They're not the same x values in all the sections, and so this wouldn't be easy to do with the method I've shown here, and we need some more advanced methods, which we don't do in this course. But if you look closely at the homework questions, that's not what they ask. They ask, will x equal 4? Solve this, or something like that. And to solve that, all you do is sub in 4 into each of these 3 sections and see if you get a true statement. So that's all they're asking you to do in that question. They're technically not asking you to solve the inequality. They're asking you to check a certain answer. So you can sub into those questions in the homework to get the answer. You won't be asked to solve one that has a different x value in each section because it's not quite as simple as the method I'm showing here. Last one, I believe. Yes, here we go. A double inequality here. But what happens is I've got the same x value in both the left and the right-hand parts of it. So this one can be isolated. I like doing these ones like this because it really helps me to see what I'm up to. I'm trying to get rid of -5 in the middle. I'm focusing on the middle. I want to isolate x in the middle. So I'm going to add 5 to all 3 sections, and I get x minus 24 is less than 4x is less than x plus 17. And now I want to get rid of those x's on the outside, so I'm going to subtract x from each section. And so I get negative 24 less than 3x is less than 17. So do you see that having the same x value on the left and right parts of this inequality made it so I could isolate x in the middle? If those x's aren't the same in those other two sections, like the one I did here, then it's not easy to solve. But again, the homework questions don't ask you to solve those. They ask you to check a specific x value. Back to here. Where was I? I'm trying to isolate x in the center. So the last thing I got to do is divide by 3 in all sections. And I get negative 8 less than x less than 17 thirds. Not the toughest set of homework ever. Nice little break for you. So knock down that homework pretty quick, and I'll see you tomorrow for some more stuff.